For this example, a doctor orders a medication 2.5 grams IV over 6 hours. The IV bags of 2% of this med solution are available with 750 milliliters in each. Your patient is an adult man, 68 inches tall and 155 pounds. How many milliliters of solution do you need to administer? There's so much information in this problem, it can be hard to figure out where to start. So as we look at this problem, we see that the doctor has ordered 2.5 grams. The doctor's order does not depend upon the patient's height or weight, and so we can actually ignore this information while we do this problem. So I'm just going to cross that out. I don't need that information. Now, I do need to know the solution strength. We talked about several different ways to set up a medication problem, but all of them include knowing the dosage strength. In this problem, the med is containing 2%, and I can change that 2% into a dosage strength because I know what percent measure means. So I know that 2% of a weight to volume solution, and I know that this is weight to volume because it is an IV solution, and I know that an IV would have to be a liquid, and I know that the medication is ordered in grams, which I know is a solid. So I know that this medication contains 2 grams per 100 milliliters, and I know that based on my definition of percentage measure solutions. Now I have options. So the one way I can solve this problem is to set up dimensional analysis. So I set up 2.5 grams as my doctor's order, and I put that over 1. I want grams to cancel, so I put 2 grams in the denominator and I put 100 milliliters in the numerator. And I do my math, so 2.5 times 100 divide by 2, and I come up with 125 milliliters is the amount that I should administer. The second method that we talked about is to set up a proportion. So in a proportion method, we would set up 2 grams over 100 milliliters because we always start the proportion method based on the dosage strength of the med. The order is 2.5 grams, and I put that in the numerator because that's where the label matches, and I want to know how many milliliters, so I put that in the denominator. In order to solve, I cross multiply, so 2x is equal to 250, and I divide by 2 and figure out that x again is 125 milliliters. The last way that we talked about doing a basic dosing problem is by the nursing formula. So our formula is desired over half times the quantity. In this case, the desired amount is the 2.5 grams that the doctor has ordered. What we have on hand is the 2 grams, and this works well because the labels cancel just like we needed them to. And then the quantity that this is in is the 100 milliliters. And so when we complete the problem, we end up with, once again, 125 milliliters as the volume that we need. Now, what is most confusing on this problem is that we did not use the 750 milliliters. And so even though there are 750 milliliters in the IV bag, based on the doctor's order, we are only going to administer 125 milliliters out of that 750. Many times we think that because this is an IV solution, we have to administer the entire bag, but that is not the case with IV meds. We're still going to administer the amount based on the doctor's order.